Hello, Algebra 2 students. This is Mr. Bear, and I'm going to talk to you today about how to simplify rational expressions. All right, so a rational expression is simply just the ratio of two polynomials, meaning we're writing a fraction. Okay? So let's start by reviewing a couple of monomial rational expressions using our properties of exponents. If I look at letter A, I have 7 over 2. Those are just coefficients and nothing changes about those. But x to the 10 over x to the 2, we're going to subtract those exponents and we're going to get x to the 8. And since that's a positive exponent, we'll leave it on the top. For the next one, 32 over 10, I could divide those by 2, so I'm going to get 16 over 5. When I look at my x's, I got 2 on top and an understood 1 on the bottom. 2 minus 1 is positive 1, so I'll have 1x left over that'll be on the top because the exponent's positive. For my y's, I have 6 on top, 3 on the bottom. 6 minus 3 is 3, and that's a positive 3, so y will be to the third power on top. And then on the last part with the z's, I've got 1 on top and 9 on the bottom. 1 minus 9 is negative 8. We don't want to have a negative exponent, so I'm going to write that as z to the positive 8 in the denominator. That's how we simplify those. All right, so those you're familiar with. Now we're going to talk about how to simplify a rational expression that has polynomials, so by factoring. So in order to do this, we need to first remember some of our factoring techniques, but the very first thing that we always want to check before we do any factoring is look for the GCF. Okay. So GCF, greatest common factor, always check for that before you do anything. Now, when you're factoring, if there are two terms, you're going to have the difference of squares. Okay. You may every now and again see a sum or difference of cubes, but most of the time it's just going to be difference of squares. Okay. That is the pattern that's going to factor like x plus a, x minus a. And that's if you had like x squared minus a squared. If you have three terms, you're going to use ACB tree, which I've also called magic X. Whatever you want to call it, you do that. And then four terms, you do grouping. Okay, so now we're going to practice doing some simplifying rational expressions by factoring. All right, in letter A, in the numerator, first thing I notice is there's a common factor of 7. So I'm going to factor that out. Denominator looks okay. So now we're going to factor the numerator and denominator, what's left over. So if I look at x squared minus x minus 2, I'm looking for two numbers that multiply to my a, which is 1, times my c, which is negative 2. And then I want the numbers to add to my b value, which is negative 1. So thinking of the list of numbers that multiply to, that multiply to a negative 2 and add to a negative 1, what you're going to do is think about things that multiply to negative 2. It looks like that's going to be negative 2 and positive 1. All right, so that will factor as x minus 2, x plus 1, and then we get that 7 from the front. Now let's move on to the denominator. For the denominator, I'm looking for an AC of 1 times negative 6, and then a b of 1. So that's going to be, what is that? Positive 3 and negative 2. So the denominator factor is x plus 3 and x minus 2. Okay, so why did we do all that? Well, we did all of that because now the goal is to simplify this. You'll notice there's an x minus 2 on top and bottom, so we're going to cancel those out. And so all that's left on top is 7 times the quantity x plus 1. And on the bottom, all that's left is x plus 3. That's our simplified function. Okay. All right, let's try another one. I'm going to go a little faster here. On the second one, I can factor out a 2 on the top, and that gives me x squared plus x minus 6. That looks similar to what we just did a moment ago. That was the denominator of the last one, so I am not going to make a new magic x. I'm just going to write those factors as x plus 3 and x minus 2. Alright, for the denominator, I can factor out an 8, and I'll end up with x squared minus x minus 2. So 8 got factored out, and now I'm going to factor the x squared minus x minus 2. So it multiplies to negative 2 and adds to negative 1. Well, that would be negative 2 and positive 1. So I'll write x minus 2, x plus 1. Okay, so now looking at this, we can see that on the top we have an x minus 2 and same on the bottom. Also, look at your 2/8. That'll simplify to 1/4. We have a leftover x plus 3 on top and an x plus 1 on the bottom. So here's our answer. Moving right along, let's try a few more examples here. For the next one here, I'm going to factor, well, first let's put this in standard form. So negative x squared plus 2x. Denominator 5x squared minus 14x plus 8. Alright, looking here, I can see in my numerator, let me use different color, contrasting colors. In the numerator, I've got a leading negative, and I also have an x in common, so I'm going to factor that out, and that gives me x minus 2. Alright, denominator, this is the longer version of the factoring process, but I'm going to show you a slightly different way to do this same thing. It'll just mean less to write out. Okay, and I will teach this in class as well, so if you aren't following here, I'll explain it in class. Alright, so as we already know, we need to take our a times our c. 8 times 5, so that's going to be 40. Our b needs to be negative 14. Okay? We know that the pair of numbers that multiply to 40 and add to negative 14, they're both going to have to be negative numbers so that we multiply two negatives to make a positive and add two negatives to keep a negative. So we're going to have negative 10 and negative 4. But rather than rewrite this trinomial out and do your factor by grouping and yada yada yada, I'm going to show you something that you can do that can shorten this process. This a value that was 5, I'm going to divide those numbers that we picked by 5. Negative 10 divided by 5 gives me negative 2, and negative 4/5 does not simplify. So this minus 2, I'm going to write that as x minus 2. And this negative 4/5, what I'm going to do is I'm going to take that 5 and I'm going to put it in front of an x and then minus 4. And I've now factored that appropriately. Okay? Well, ignore this kitty. He's trying to get in my face here. Okay, so I've now factored, so now we want to look and see if anything cancels. I see an x minus 2 that cancels from top and bottom, so all that I have left is negative x on the top, and then I have 5x minus 4 on the bottom. Okay? Alright, let's try another one. On this next one, let's see, this one is a factor by grouping, so we're going to have, we're going to take the first two terms together and the last two terms together. And let's see, we can factor out 6x squared on the first group, and that gives me 7x plus 1. In the second group, I can factor out a negative 1, and that gives me 7x plus 1. Knowing what we've done in the past with these, that means that I have 6x squared minus 1, that's my GCFs, and then 7x plus 1, that's my numerator. For the denominator, let's see, I can just go to grouping. I checked for GCFs, but there wasn't one. It was close, but the last term did not have a GCF. All right, looking at the first group, 12x cubed plus 6x squared, I can factor out 6x squared, and that's going to give me 2x plus 1. And then I can factor out a negative 1 in the second group, and I get 2x plus 1. So now we know that'll factor as 6x squared minus 1 multiplied by 2x plus 1. Okay, so now that I've done that, I can see that my 6x squared minus 1s cancel out, so I get 7x plus 1 on top, 2x plus 1 on the bottom. And there you go. All right, next one. Looking at the numerator, I see a GCF of x, and then I get x to the fourth minus 19x squared plus 90. In the denominator, I can factor out a 3, which will give me x squared minus 8x plus 15. Now that I have that in the numerator, I'm going to factor using my ACB tree. So we're looking for two numbers that multiply to 90 and add to negative 19. So that'll be negative 10 and negative 9. My a value, which is in front of the x to the fourth, is just 1, so I don't need to do anything special. So I'm going to write that as x squared minus 10 and x squared minus 9. In the denominator, I'm looking for two numbers that multiply to 1 times 15 and add to negative 5, so that, or sorry, negative 8. So it'll be negative 5 and negative 3. Okay, so we're getting closer. In the numerator, I can see that I have this x squared minus 9. And we should know that factors as x plus 3, x minus 3. And in the denominator, we have 3 times x minus 5 times x minus 3. Canceling out the common factor of x minus 3, we can see my numerator will be left with x times x squared minus 10 times x plus 3. And the denominator will be 3 times x minus 5. That one was probably one of the toughest ones we'll see, so sorry that that was a lot of work there, but if that's as hard as it gets, then that's not really that bad. Okay, last one here. In the numerator, let's see, no GCF to factor out, so I'm going to go right into my ACB tree. A is 6, C is 3, so two numbers that multiply to 18 and add to negative 19. So I'll be negative 18 and negative 1. We do, in this case, have an A value of 6, so I'm going to divide these by 6. And I'm going to get negative 3 and negative 1 sixth. So I'm going to factor this as x minus 3 and 6x minus 1. So I had a denominator in that second fraction, so it flies in front of the x. All right, in the denominator, we're going to factor out a 4 here, and that'll give me x squared minus 9. And because of what we know about that, I'm going to rewrite the numerator, but the denominator, the x squared minus 9, will be x plus 3, x minus 3. And we can now see that the x minus 3's cancel out, so I get 6x minus 1 on top, and then 4 times the quantity x plus 3 in the bottom. Now, for those that might be asking yourself, how come I'm leaving everything in factored form and I'm not multiplying or distributing out? Well, the reason I'm not doing any distributing or multiplying out is because when we talk about our next lesson, the factored form is going to be the preferred method for how we find certain elements of rational functions. Don't worry about what that means right now, but just note that that's what's coming. Okay, last piece here, and that's going to be how to apply this to a certain situation here. So let's say Mark is making a smaller version of the soccer field that we see here. Write a simplified expression for the ratio of the perimeter to the area. Okay, so perimeter, add all the sides. Sorry, area, length times width. All right, so in my numerator, I need to remember that both of these sides also exist. If I add up all my sides, I have 2x plus x plus 2x plus x. So 2, 4, 5, 6. So 6x. And then I have plus 8. Now for the area, we're going to take the length times the width. Okay? So I wrote 2x multiplied to x plus 4. Don't distribute this because what's going to happen instead is that we're going to factor the numerator. I can factor out a 2, and that'll give me 3x plus 4. Okay? And the 2's can cancel. So the simplified ratio is 3x plus 4 over x times x plus 4. That's it. Now it's time for you to do some practice.